Alright, we good? Alright, we're good. Let's go. Oh, not that. Wrong solution. Okay. Where did we end up last time? How far did we go? Oh. Oh, here we go. Range-based and enums? It can't be related to the index, can it? Because we don't index the value of enum. The value of an enumeration was that, let's see. Let's say arrays in general. Well, I mean, the main benefit is that we can loop through the array using enum values to pull out what we want. So I can put in a specific value. It's really, well, a specific value, an enum value, an enumerator, that implicitly converts to an unsigned int, which can index a standard array or vector. We can loop through it. But for a for each loop, or a range-based for loop, there's no index, right? We're just saying for element in this array, do something with the array at an index or the element. I mean, if you had an array of the enum, maybe there's something. Okay, I'm not sure. To iterate through the enumerators of an enumeration, huh? To iterate through the enumerators of an enumeration, meaning an array of all the enums in it? Yeah. Oh, too hot. And so what the point was, we would have a standard array of the colors up here. For auto element in type. Yeah, I wouldn't imagine that you would. It's not, I mean, unless an enum under the hood was actually an array, then that wouldn't help. Excuse me. Gotcha. So we can output the enum as its value, and we could loop through our enums. So if we stored, well, we could loop through our enums from basically 0, 1, and 2. So for 0 is less than max colors, output this guy. But it's really output the index, static casted to be the enum. I mean, that's what I was assuming in the beginning. At compile time, we would create a standard array. What is the case where we would want this, though? Could you have an array of arrays to do this? So, like, we have an enum, and the enum is all of the different cheap types of enemies that we have in our game. And we have the array, we have the enum, so we have the different values, troll, ogre, goblin, all that stuff. And then we have a standard array of all of those enums, or the enumerators, in a standard array. And then we have another array that is an array of arrays, so that we can use the first array to loop through each element, or not an element, but loop through each enumerator. So let's initialize all the goblins. Let's initialize all the hobgoblins. Let's initialize all the fucking whatevers, okay? And so we loop through the array, and each array is an array of that particular one. So for example, goblin is our first enumerator. It has 0 as its value. So we could do a for loop and just do for. You do index 0 or index is, well, yeah, that's what you do. You'd say index 0 up to the enemy max in this loop. Index the array for that particular type. So we're on 0, goblin. So we index the array of arrays. So the monster array, that is an array of separate monsters. Because it's an array of different, let's see. Yeah, I guess that's how it is. So it's like, I mean, this is how the world in real life is, right? So if I just think of like the different races in the world or the different nationalities in the world, we could say, I have a big array that is an array of Americans, an array of Middle Eastern people, an array of British people, an array of this, all these different ones, all these different places, countries, whatever. So that for the American array, we have all the Americans. For this one, we have all of these. For this one, we have this. So in one array, we have all of the orcs in the game. We have all of the dragons in the game, all of each one. So what we do is we have one loop that loops through each enum value because it's stored in an array. So we loop through that array that has all the enum values. We assert at compile time to make sure that it has all the enum values. So it's like a way of getting around the fact that we can't just loop through the enum values. So for each one of those, we index the monster array that is an array of monster arrays, or it's like the, what do we call it? The world monsters array. In each index or each element is an array of that specific monster. So we pass 0 for goblin into this index, or into this array. So we start at 0. That 0 is passed in as the index to the array. So we're now in the goblin array. And now we can loop through the goblin array to spawn them wherever they need to be. How that would be found? I guess really it would just be the instances of the goblins. So we could say like spawn the 10 goblins, or the 10 goblins already exist in the game, let's just say. And let's say that at compile time or at the runtime in the program, those instances are all stored in the array. And it could be an array of, you know, that's probably what it is. It's an array of either references to the goblins or pointers to the goblins. And we'll do standard vectors because instead of standard array. So we could have a standard array of standard vectors. The different types of monsters in the game will not change, but the amount that each monster has. So there are one dragon in the game, but maybe there's another one. So we need to increase the size of the array. Okay. Yeah, I could see that. That could be cool. And then you could have other stuff that says how you could have another array that has how many of each goblin there should be. Okay. So it'd be like goblin index is passed into the goblin array to get the goblin itself and spawn this many or different stuff like that. All right. So I can trying to see like when we would actually want to loop through an enum. I mean, if you had like a shooting a plane Air Force kind of Navy game and you were flying a plane, maybe at compile time, well, not even at compile time, at runtime, you loop through the different types of, let's see if this is even needed. You could run like a validation check on each type of, what do you call it? Like, not artillery, like payload, each possible payload to see if it has it and whatnot. And you can, for each one, you could check if it should have one, and if it does, then you update the plane object to have it. That way at compile time, you basically have like that array would almost be, it would basically be a data table. It would say, hey, in the world, we need this many of this payload in this plane, this many of this and this many of this and this. And at compile time, we loop through and we, let's see. We can maybe create these objects at compile time, like create the various different planes, again, and have them be initialized properly. Oh, and the class could update its values based on info in that array, maybe. Well, yeah, because if they had the same value, like 0, 1, 2, 2, it wouldn't really help, right? Okay. Yep, and so we can loop through this array of enums. Enums just defined somewhere, so we have an array of them. We can loop through them and print them by name. And in printing them by name, you call the function to actually get their name. So you have to write a function or an operator overload to teach the insertion operator and standard character output how to output an enum. You also need a function so that it can get the name. You also need an array of the names that this will use. And then you also need an array of the enums that you're looping through anyway. Well, yeah. Yeah, of course, that makes sense. Yep, there it is, data. Yeah, now we could index, so we could have an array of, we did this previously when we had switch cases where we taught, well, we used an enum, but we used a switch case and a function, and we would pass the enum, and it would switch on the enum and put the proper amount of legs out. but we had to make all these different cases. One case dog, 4 legs, case cat, 4 legs, or case dog, case cat, 4 legs, with fall through. That way dog and cat both fall through and have 4 legs. But now we just return the index of the array that is legs, or in this case, say, oh. So instead, this is actually an array of objects. Not an array of arrays, but an array of each individual object. That way we can do index it properly for dog. So pass the dog enum, which is from a for loop, because the index. We do, what did he do? Oh, we're doing range. I forgot we can do range based, yeah. Oh, shit, that's true. Okay, so it's kind of what I was thinking in the very beginning, but I didn't fully flesh it out. So we can use a range based for loop and properly index an array specifically by having an array of those elements. And we can go through those elements and pass those elements as indices in there. I think I might have got the net. I don't know. I had to go all out. I think he's probably fine because he probably only got blunt forced. I hope he's dead. Raja Jackson. Chill time, bucko. Alright, let's go. We have a namespace for animal. We have the enum of the different ones. We have a struct for the info for each animal. And then we have a standard array of them that user enters the name. So we extract input. We find out which one it matches or it doesn't. And then we print out the animal. And then print out, oh, let's see. Print the data for that animal. Then, excuse me, print the data for all the other animals that didn't match their input, huh? So what, we have a function that is print other animals? I'm not sure. Let's just get the structure first going first. Let's get the foundation going. Let's do this in other files. Nope, he's alive still. All right, so we need, we'll define this here. Chicken, dog, cat, elephant, duck, snake. Chicken, dog, cat, elephant, duck, snake, max animal. Struct animal data. Don't even know if we need the animals.cpp at this point. No, we will. So we'll say an array of the names. We'll have an array of, okay. We'll say sure. Yo. Why not? Wait, why not? Right, you fucking... What? Huh? Why not? Still no? Wait. Am I just doing something wrong? Just gonna test this real quick. Oh, well, that was the issue. Alright, so really we'll just do it here. Oh! It can't be in a struct. It was the location where it was because the struct isn't const expression, the element of it is. So we could make a const expression struct and this would become it, but okay, alright, that's why. Okay, it was just because it was located in the animal. Alright, good. In the animal data. And animal data shouldn't have had that anyway. I was just being stupid, I was blind. Excuse me. We'll just do this for now. But we're gonna need an array of this too, because this is gonna include the name. Name, number of legs, sound. The strat for making it so we don't have to do. Oh, we could do okay, but in the animal data, it still needs. Okay, so we need a standard string view name. Okay, and we'll say chicken, 2 legs. Fuck. Hold. So it still needs. I think I got the net. I mean, because this should work, right? Hold. Oh. If we remove that and add this, even then, no? Okay, I don't remember. So we have chicken, dog, 4, wolf, oh, and we could do it like this. What do they even do? Like, what does an elephant even sound like? Elephant sound, we'll say. Duck, 2 legs, quack. Oh, this is some. Let's go back to this. Guess we don't need anything else, huh? We have any function? What function are we gonna do? Oh yeah, we still need to get input, right? So ask the user to enter the name of an animal. So we need to be able to convert the name the user entered to an animal. Okay. And so we'll say get animal name from user. And so or get animal name from user as animal enum. So we return an animal, get animal from string, or string to animal, or get animal as string. Okay. And I'm gonna make functions do exactly what they do. No extra shit. If it means a bunch of extra functions, okay. So that if I say get animal, I don't have, oh, it guaranteed has to prompt the user for this, and then I have to take the prompts out and put them into its own stuff. Excuse me, we have a main function for a reason, so it's fine. Alright, get animal as string, so we're gonna use a I also need a standard string. Well, not here though. Okay. And we'll say standard string user animal, or string animal. Okay. And this is probably one we could just include up here. Hello? Hmm? Bro, did I spell something wrong? What is happening? Why are my eyes hurting right now? Ugh. Ugh. Probably because I look at a screen every second of my life. Okay. What is happening here? Hmm? I don't know what was happening there. Okay. So we'll loop through the animal names. Do we have to, I think we have to index them. I don't think a range-based for loop works here because I need to return the actual value and I need to use the index. And then we could just we could do it either way. We could do for this guy. I think we do. Screw it. Let's just do it. For, or we could say, excuse me. Yeah, I think that's what we do actually. We'll say for animals, or we'll say animal enums, or well, animals as enums. Animals data. I mean, I like animal data. Okay. For animal enums, or animals as enums. I prefer, well, sure. And really, this should actually be const auto reference this animal. Well, this animal. For each of these, we index using this animal. Or, sorry, not here. If string animal is animal data. Why are there two? Okay. Is animal data indexed with this animal, not name, then return this animal. But this doesn't return in all control paths. So at the end here, we need to return another animal. So we could say return max animal. So we could say get user animal string. Check which animal user animal string matches. Sentinel value. And when match fails. Okie doker. True. We could also do a static assert that animals as enums size is max animal. And we can also do this here. Oh wait. Oh, okay, yeah. Which wasn't used to. I saw this not at the end of a regular line, but at the end here, and it was looking like a type definition to me. It was weird. Static assert that the animal data size is max animal as well. Ensure all animal data exists. Ensure we're storing all. Ensure all animal types are stored. String view literal suffix. Okay. So we can get the animal now from the user like this. And then I think we also have to include this in the header file. I think we do the teaching. Maybe we don't. No, I guess we don't necessarily, huh? We could do standard. So what are we going to do? We're going to do, oh, and we'll use get animal string hold. Don't we do this in one? Wait, hold on. What's happening here? Oh, oops. Okay. It's a good one. It's a new random playlist. I'm using my brain right now. I don't really want that. Let's say Gnat. So instead, this is getting the string. Do we want this, or do we just do get animal from string? Get animal from user string, and instead make this be standard an iStream reference. Right? Operator insertion, standard iStream reference, in, and then animal, user animal. Okay? And in this case, we're just doing in to string animal to store. And so this is also a reference. And so what we do is, if this is true, we need to handle input failure too. So this will be, we're gonna say user animal is this animal, then match found, if match is found, or if string matches animal, and we'll save the animal, and then save animal and early return, and return in. If it doesn't, match not found, fail in, or we'll return sentinel value and fail input. So we'll say user animal is max animal, sentinel, and then we'll say oh, so we could say failed it. Is it that easy? Set state, and we'll set the state to be failed it, right? Where's this from? This is from... Is it iOS? It should just be 0. Oh! It looks like it says 2. Okay. What if we didn't have that? Doesn't all... Yeah, makes sense. Okay, cool. Send no value. Fail input. Match not found. Extract sentinel value. Fail input. And that's it. Fail input and return. Excuse me. Okay, that way we can fully extract input from a user's string. Now we don't need this guy anymore. We just need standard iStream reference, operator insertion, standard iStream reference, in animal, user, animal. Say your definition is totally found. Right? Oh, oops. That is why I forgot to put a reference there. Okay. Now what else do we need? So we need to get an animal from the user like that. We also need to print that animal's information. So we'll say include animals. And then we could say enter an animal. What does this look like? Oh, we totally did not insert anything. So enter an animal. Okay, an animal. And then animal couldn't be found. And then, okay. Enter an animal, and then we'll say animals, animal, user animal, standard character input extracted for user animal, and then if user animal is animals max animal, then your animal couldn't be found. And then print remaining animals. Get animal, get user animal. Check if valid animal, or if known animal. Alright, let's see. So we could say if the animal is max animal, it's not found, and then print remaining animals. And then we could say instead else output all the information, else print animal, user animal. Okay, so now we need to take a user animal or an animal and print its information. So we need a function, it's void, and it's print animal, and it takes an animal, animal, and we'll say user animal. Okay, and what it does is outputs. We could make it instead of this condition, we could have it be checked in the function. I think that makes more sense. So we could say here, animal couldn't be found. Otherwise, it'll actually print the animal. Use animal, print animal, print user animal. And I think it's just going to be one. It'll just be standard character output. A something has this many legs and says something. A animal data user animal name has animal data user animal legs has that legs and says animal data user animal dot sound, okay, and says that, okay. And is there anything? I think this can be const expression. No, it cannot, because it uses standard character input and output, or just input actually. Okay, so it prints this animal, and then we'll say, oh, this guy's too quick. It's a little baby. And then we could say print animal data, void print animal, animal user animal. Is it that? Yep. It's cheap. It's an enum. We could pass by value. It's fine. I think it's actually cheaper than even passing by reference. Maybe. Yes. Because assuming that we store addresses as integers, then storing an integer is cheaper because storing a reference also requires you to go and use the reference too, not just use the value there. You have to store the value and go and do it. So you have to access the memory, access the value, and assuming it's stored the same, one integer in both cases. If we use it as a value, we just use it. Boom, we got it. But if we use it as reference, we have to use this value to go and get the real value. Excuse me, because this value is a reference. Excuse me. So that's this animal we've printed. And then we need to print remaining animals. So we'll do print remaining animals. That's void print remaining animals. And it'll take animal user animal. This didn't help. Print animals that user didn't enter. Or print all other animals. Print the non-passed animals. Print leftover animals? Not sure, something like that. Print this animal's data. Print leftover animal data. Okay, and so we'll say void print. Ow! God, I feel like a fucking fire ant bit my foot, dude. Print remaining animals. Animal user animal. Okay. And what if we just did standard character output for the animal instead of this? Isn't that better? I think it is. Oh, what the fuck am I doing? OStream reference. OStream reference. Okay. It's better. And then print remaining animals. We'll leave that as is. And we'll pass in, so we'll say for animals as enums. Oops. For const auto reference this animal. For that, if this animal is not user animal, then output animal data this animal. Hold. We also don't have. Yeah, I could do this better too. We need one more thing. I'm debating whether we even put these. I'm debating whether we even have these standard arrays out here. Print remaining animals. What's happening here? Oh, well, this isn't defined yet. Okay, that's why. Oh wait, what the fuck? What the fuck happened here? It's just that nothing fits it, so it's checking everything. What is happening here? Oh, expected a. Oh, there it is. What are you still tripping about? So we also need a way to print this type of animal. So we'll also say standard output stream reference. And this should actually go first. Print animal from enum. Print animal. Well, actually, let's see. Print animal from animal data. OStream reference, operator insertion, standard OStream reference, out, const animal data reference, user animal, or this animal. Okay. And this is where we might do it. I think we're actually going to move this into here. Well, hold. So this we're passing in one animal. And I think this is just output this animal name. Has this animal legs, and says, well, legs, and says this animal sound. Okay. And so instead here, it is output animal data user animal. Boom. And this also needs to return output. This also needs to return output. So this prints the animal from the animal data struct, and this prints animal from animal enum, which checks to make sure that it's actually valid so that we're never calling this. And we'll say that this guy is static, and we're not going to forward declare him anywhere. And then we'll say print remaining animals. Prints all animals except the passed animal. And now we can print the data of that animal. And we end the line after each time. Okay, this seems okay. And so now we say get an animal, create an animal, get the animal. Or we say we prompt for an animal, create the animal, get the animal. And then user animal, we can print the animal. And then print remaining, oops, hold. Animals, print remaining animals, user animal. And we'll say dog. And this should say remaining animals. Through all other animals. Yeah, and we could, and if we extracted max animal, it's not going to print it. And if we tried to print, okay, I think this actually works. What if we say A, invalid animals, and then it prints chicken, dog, cat, elephant, snake, or elephant, duck, snake. But if we do elephant, oh, that's right, elephant, it does chicken, dog, cat, duck, snake. And we'll do enter an animal. Dog. The dog has 4 legs and says woof. Chicken, cat, elephant, duck, snake are left. Okay, and we could make these like this with a little asterisk action to make it be like a sound effect. pigeon. Doesn't say shit. Chicken, dog, cat, elephant, duck, and snake. Anything else here? This guy can't be made constant expression, nor can this guy, nor can this guy. And nor can this guy. KO. This guy's static because we're never actually we're never storing the animal as animal data. And I mean, do we even care? Let's see. Do we even want these to be? We want animal to be here. I feel like we don't even want the big list of animals to be out there. I feel like we want them to be here, huh? Because we're never going to use them, so we may as well just hide them. We want animal type to be used elsewhere. The animal data should be held like a repository, right? But then same for animal data too. Same for this assert. We just want the functions, I think. Okay, because we want the animal declaration so that we can actually use an animal. We want to extract and output animals. We also want to be able to print the remaining animals, so all but one. And then here we want the animal, so the actual animal types that are stored, animal data that is stored, and then this is fine too, and then the implementation for extracting. Okay. Feels like it's okay. Also create a struct named data to store the animal stuff. Cool. The user enters the animal. If the name doesn't match, tells them, and otherwise prints the data for that animal, but then it prints all the remaining ones. So in the event that they put a proper one, it puts that proper animal and then prints the others. But if they print one that doesn't exist, we say it doesn't exist, and then we print out the rest, which includes all of them. So we'll say giraffe, invalid. These are the remaining animals. Cat, print the remaining animals. Let's check about improvements. What do we think, huh? So we'll say, I want to get in the habit of being able to read all this shit without having to collapse it. Okay. Animals as enums. This doesn't even need to be inline because we're not including it anywhere else. So that's fine. Maybe these might need to be inline so that we can define the overload in multiple places. Maybe not. Never mind. They can't be inline. Okay. Well, what was the issue? What was the issue when it was? Oh, scary. Hmm? What if we made it inline here? Oh, okay. Interesting. It can't be made inline. All right. I think these are fine. Oh, this guy also doesn't need to be inline anymore because we're not including him anywhere else. For outputting, take a string from the user. We get which one matches, and if it matches, we return that animal. Oh. We can output them from the animal data. And then when we do the enum, we just pass that animal to the array and print that one. That way there's nothing to change. So if this guy changes his implementation, it could be the same here. It's still simply output animal data like this. And we could say we could do an assert that the animal data, well, if we're passing an animal data reference, I guess it's fine. It's just that when we're outputting from an animal itself, we want it to be one of the ones that we know. Yeah, honestly, this all seems fine to me. Do I have a timer going? Cool. Oh, wow, it took up some time. What the fuck? Oh, what, really? Excuse me, 17 minutes left. Wow. Okay. Oh, because it's till 07. Gotcha. Okie doke. So what did he do? He did string and string view, array and IO stream. Sure. Yep, we got the animals. We have the data. That name sucks. We have ensure that, and maybe that makes the most sense too. We store both of these and then we assert that they're valid instead of doing one and then doing one. It's like do one and then kind of ignore a piece and then define the other and then ignore another thing. It makes sense to just compartmentalize these. Like type definition, actual stored values from those type definitions, and then validations or assertions together. Teach input. He didn't teach output though. Oh, and he also has another one, print animal data. Are you sure? Like all the time we've been mixing this up. Alex didn't create this. Somebody else created this. He didn't give kudos though, so maybe it was him. Maybe the other people were the ones who weren't slacking. Because normally he's not slacking like this. If he's normally consistent. If we're using standard character input to extract a type, normally we also use standard character output to print the animal type. But instead, he's doing this extra shit. And here, he's checking instead of building it in. Like, I'd like to build into the... I don't want my main function to be checking to make sure that we did... Or that the damage we did to the... Like, so if we're printing the damage we've done to a character in a game, I want the damage dealing function to handle whether damage is 0 or not. I don't want to only print when damage is... I don't want to put in main these extra conditions. I want the functions themselves to be as robust as possible. I don't want them to just just do anything. For example, standard character input, I technically missed a piece there. I want to do input validation to make sure that our shit is valid. I don't want just to have a function that's standard character input and it's awesome and cool because I can pass whatever the fuck I want to it. No, bro, I want to extract something and make sure that it's actually valid. I totally fucked up here because I just forgot. But yeah, I don't want to just have 10 different functions and they just do whatever they want. If I have 10 different functions, one of them better be validating some shit and making sure we're cool. Okie doker. Seems good to me. Excuse me. All right. And so it begins. I was gonna say this one has to be longer for sure. There's a lot of stuff here. I mean, we've been hearing about C-style arrays since my birth. I'm gonna do push-ups in a second with this music. Standard vector and array, and now we have the last one. Nice, C-style arrays, the built-in containers. Hold on, let me just get ready for this. I'll keep going as long as I can. We'll do speed. I'll go to the beat now. Oh fuck, I'm such a wimp. Go, stop. Oh, pause for just a second. Go. Fuck. What is that? Oh, just a piece of the carpet. I'm gonna finish this out in a second. I can't even read that from here. What the fuck? My eyes are messed up. Here it comes. Fuck. Keep going. Fuck. That's all I got. I only have negatives now. Oh. Alright, that's all I got. Song's over. It's fucking hard when you go real slow on negatives. Inherited from the C language. Built in unless the others, yep, because those are defined inside the standard library, as we know. Because we gotta include them bitches as header files, because that's where their definitions are included, or defined rather. Fuck. Out of water. No including needed. Yeah, because otherwise, I'm curious how else you would even define or implement arrays and vectors if you didn't have access to some built-in array type, right? Seems like you wouldn't. You'd have to have. I feel like you have to have something lower level defined in order to use it here. Unless you could do something with for loops and new and delete to create keep variables. I'm not sure. Oh, damn. Okay. Their own special square brackets to say it's a C-style array, and optionally provide the length. Gotcha. So if we're reserving memory in the beginning, in advance, boom. So I wonder if C-styles are. Do they? I guess they don't have a size, huh? Oh, but can we do standard size? That's the point. We do standard size because it isn't a member function, because C-styles aren't type definitions. So we could say int e, sure, an array of them. And let's say we've got 10, 20, and 30. But then I'm curious, is there a standard, oops, size? Oh. Oh. It's an X utility, huh? X utility, standard size and standard S size. What's the length? 3. But if we make it 0 and say 30 here, it's 30. And then what happens if we do standard shrink? Nope, doesn't work. Because I think it might only be a member function. Let's test. Nope. I don't know if they can be reallocated. I think maybe standard vector is the only one that can be reallocated to be smaller. Well, actually, let's see. Oh yeah, because there's no member function, so there's no pushback. What about standard push? Nope. Okay, I'm guessing we're not going to get that. We just get whatever the size is. Whenever the Forever Winter comes out fully, I'm curious. No mention, huh? Just these graphics are really up my style. Just everything's a little scuffed. And the music and the ambience. I don't want to get it early access. Okay. 30 elements of type int. Are they uninitialized or are they default or value? Oh, they are value. Nice. Good. Yep. Yep. Where's decay? Oh shit. Nice. The length must be at least 1. Dynamically allocated are allowed to have length 0. So what if we said int e doesn't have an, huh? What if we put in 0? What if we said new? Even then, no, huh? Okay. I thought new was the way to do that, but I guess not. Okay. 0 negative or non-integral, okay. The array length must be a constant expression, so we can't put in a regular integer in there. Makes sense. Needs to be known at compile time. Excuse me, because we could put in a literal or any others. And I think and C style arrays are the ones that we can get by doing dot data for a standard array or a standard vector, which allows us to use signed indices to index them, or signed integers to index them. It's a better way of saying that. With non, C99 variable length arrays should not be used. Okay. Okay, don't touch variable length arrays. Subscripting like normal. So we can edit the first index, so the second one. Right? Element 1 meaning the second one, not 0. So there are 5. So this is 0, 1, 2, 3, 4. Oh, I was ready to, but I guess not ready enough. Okay. 30 minutes of rest and maybe trying to figure some stuff out. So I'll be back in a bit.